So initially, we decided to use a one-piece frame, one piece of cardboard, so that we can have the maximum structural stability and strength, because it's going to be hanging down. So we thought of a cylindrical sort of design, a way we can like kind of roll it up and then we can hook it on. But then later, when we discussed it with the group, we brainstormed that we should have more of a triangular shape, so that we can have a flat base and we can put weights inside, which is going to be stable and not going to be rolling around. And then later, we decided to have more of a rounder edge, so that we can have more weights in there while still retaining the triangular shape. And we also did some calculations in order to use the maximum cardboard that was available to us.
We were able to fit a prototype and the main machine with just one single sheet of cardboard. And yeah, we needed to do calculations to make sure that we utilize the cardboard as much as possible. Something else that we did that was very interesting in my opinion, we wanted to distribute the load evenly throughout the whole base. So we built a, maybe I should take it out so you guys can see this a little better. We built a platform on the bottom that distributes the load evenly throughout the whole thing and keeps it stable and flat. It also, as you can see, there's a little bit of compression forces. When you are holding a triangle down, it's going to want to squish and fold the base in, right? So then having a solid foundation to keep it open turned out to be very important at the end of the day. Something else that we did, load dispersion. As you can see, we used a single stick to hold all the tension, all the elastic ones, I guess, so it wouldn't rip the cardboard. At the end, I think we were very happy with our design. It works very well. Let's test it. So this is with 3 kilograms. We tested it up to 3 kilograms yesterday, but I'm sure that we'd be able to do quite a bit more than that, hopefully. Feels all right. Oscar, would you mind grabbing a few more weights? Test it maybe with like 5 kilos or something like that? Yeah, I think those are 500. They're a little bit smaller.
Except for these are all 500.
Yeah, these are all 500. We haven't tested with this much weight, so hopefully it's not the end of the world.
If it does break, we'll consider the initial run.
We also put a little bit of a dorm. We figured gauntlet needs safety, so we have a little bit of yes. Wow. Okay. Close. All right. This is with 4.5 kilograms. Are you holding it steady? Perfect. All right, let's give it a go. Wait. Variable geometry. If we tighten the springs a little bit more, it'll shift the balance to the left. So this way, it's a little bit better in my opinion. Beautiful. I'm sure that we could go for more weight, but I don't imagine that that's too important. We already have a safety factor of more than 2. The design weight was for 2 kilograms. You have something to say about this?
Yeah. So this was our initial prototype, and some of the things that we changed was the shape of it. We added the wooden board so that it would distribute the load evenly, like you mentioned. Like this one didn't have any. And another thing is that when we tested this one out, it wouldn't keep the triangle shape. So what we did is we added sticks here to keep it, at that angle. And also, yeah, one of the things is that we adjusted the height of this so we can fit the weights, but with this one we couldn't. And also thing I should mention is that with this prototype, we managed to fit 1.5 kilograms.
Some things that we thought were very important were sustainability and being able to repair this machine, right? So we figured what would be, this is for
10 seconds.
Upgrading into a higher thing. We added a little strip of cardboard right here that could be replaced cheaply and easily. I don't think it would be an issue to do that rather than have to replace the whole frame of the thing. We figured it'd be good if we were to upgrade it to like a real gondola.
Thank you very much.
Thank you. Sorry for not waiting.
Okay, we've got 10 minutes for questions.
Of course. set this down, please, it's a little bit.
How much was that holding in the end?
$73.
$73. We came a little bit.
No, sorry. How much weight was it holding?
4.5 kilos.
4.5, okay.
Yeah.
You spent $73 or you used 70?
We spent $73.
Okay, I don't think you ended up using all of that.
What is your team name?
Our team is Marine. We're from Anonymous University.
Oh,
Yeah.
Oh my god.
You were like, university, because I thought you were gonna reveal it, I was like, no, I don't want this team to follow. Yeah.
That was a trick question.
Oh, no, I wanted to.
Okay, I have one over here.
Yeah, go ahead.
So I really like the adjustable elastic tension part of the design.
Yeah.
But my question is, in the real world, if this was a real gondola, how would someone, or what would be the practical application of those adjustable
Well,
tensions?
Originally, we wanted to do when you look at a gondola, you see that they have springs for hooking onto the machine, right? So this is more like a callback to that. I don't imagine that it would have application for a gondola. Gondolas are usually very well balanced, right? We weren't really able to do that with this model because it seemed a little weird, but it was like a callback to the attenuation and springs that the gondolas have to keep the gondola from shaking too much.
Yeah,
It
it
was
could
more
also
like a
lead
happy
to
trip.
a more comfortable ride for the passengers. And it would also depend on the load which is being carried. So whether it be like people or products like construction material or something that needs to go up, it could also depend on that.
Do you imagine in real life, would those actually be adjustable, or is this only for testing purposes?
This was only for testing, yeah, because we had an issue with the prototype that it wouldn't stay in balance. So this was like our way of fixing it. In the real world, I am sure that we would have a little bit more time to balance it and make it perfect.
We were trying to keep it stable throughout the way we use these elastic strings so that we would be able to have a smooth ride, because with our initial prototype, it was not very stable. It was kind of it was not giving a really smooth ride that we wanted, so we wanted to have these strings and this rope the way we attach these springs in here, so that we would try to keep this thing stable as it was going through.
The idea was that we would keep it a little bit more parallel to the ground by having a different tension on these blue strings. So then the front would be a little tighter because all the weights are going to be at the front and the back a little bit looser. Any more questions?
What were your considerations around material use and how to reduce the material waste?
Okay, so we only used cardboard, string, the popsicle sticks, and the elastic bands. So only those four materials. And we tried to, as Johan said, we were trying to maximize the amount of cardboard that we're using. So when we first had the initial prototype, we then found the initial calculations to determine how much cardboard we would need for the final prototype. And we tried to maximize the string that we tried to make our device as durable as we could with the elastic strings. So we really tried to maximize the amount of material that we had using only four objects.
We also attempted to think outside of the box, and when we bought the ball of yarn, it was wrapped up with that friction pad where that rubs against the string. So that was something that we didn't think we would use that we ended up using.
So you ended up using that without the yarn, right?
Sorry? Well, we did use the yarn, just a little bit. At the top, it's for, that way we could balance it at the end.
Oh, I see.
In a real world version of this, how would you deal with thermal comfort inside the cabin?
Thermal comfort inside the cabin.
We'd probably have an enclosed cabin,
Yeah.
both sides. So,
Thank you.
that would-
Yeah, we did try to put a wall to the top of it, but we just thought it looked a little ugly, realistically. That was the main reason for taking it off. Maybe we shouldn't have to.
So you'd have a wall out there.
We would have a wall on both sides.
Would you have any views out of the beautiful Burnaby Mountain, or?
Yes.
We were debating on whether or not we should put windows on that. We decided to put just 3 Oreos and milk instead. We're gonna throw some windows on as well.
What's that?
3 Oreos and milk.
That's
just
our
Oreos
team
and milk.
Oh.
This was just,
I thought that was a sponsorship ad, actually.
Have you thought about the accessibility for people with mobility issues?
well, we do have the door that opens and closes, but I don't think it opens all the way down.
Yeah, but
It opens pretty close, but there's a little bit of a problem. I guess you can push it down. Yeah, that's a little bit rough. It's such a small model. In the real world, what would matter most for that would be having the floor and the gondola cabin level where the intake of passengers is. But for this model, that was really
Yeah, we would have many more considerations in the real world, like accessibility, like windows for people and the enclosed space. But this is the model. This is just a rough model. So, yeah.
What would the user experience be like?
user experience.
Well, what would it be like if you were a student in that gondola, what would your
Probably,
experience be like?
we wanted to keep it as steady as possible just so we can do that homework in
Yeah.
computers. That was our plan.
Do the homework?
Yeah,
So
of
what
course.
would be the duration, you think?
We'd probably get it to do a couple of loops before we
Yeah.
finish the homework. I'd say so.
What design and testing considerations did you guys take to be confident to put initially 3 kilograms into your design? Or into your final demo, sorry.
The fact that we were able to get 1.5 kilos in our first prototype and without using any doors, we just bent the cardboard. So we knew that this would work. And so we try to make it a bigger, more stronger design. And so then we started with adding more. And
Yeah, of course. To add on to that, we also had some issue with the this part right here. When we first tested it with 2 kilograms, it was bending quite a bit and it felt like it was about to rip. So what we decided to do is tie a string here to there, and we would have a full loop. So when you're looking at it this way, most of the stress is being applied on this rope and the whole loop all the way around. So the cardboard, which is probably one of the weaker areas that we have, would be supported by the extra string and rubbers and rubber bands.
Now, follow-up question to that, if you guys had more time and resources, what would be some ways to test more weight onto your gondola as well?
We could have tried to make the device maybe a bit longer and more wider, though there would have been some issues. We probably would have extended the base a little bit more, because if we added more weight, there could be a problem that this thing could possibly fall in and on itself. So there would probably have some sort of system underneath just to keep it more stable.
Yeah, we could have also done a bit more calculation on to make sure that it sits horizontal, the base stays horizontal, to make sure that this completes a triangle, a symmetrical triangle. Yeah.
The
Yeah.
support side is curved and the other is straight.
Yeah, so that's because a triangle loses a lot of the volume, when it's being pushed up. So we figured that if we put this curved section, we'd be able to gain the volume back and have the rope be the load-bearing area instead of the actual wall of the machine. I had something to that, but I forgot.
I have a question regarding the way you use friction to go down the rope. In a real world situation,
Yeah.
that type of design would be kind of following the angle of that rope. So for the users inside a cabin, that would be problematic. How would you solve that in a real world application?
Well,
using that same concept?
Using the same concept, that would be a little difficult, but hinges is sort of the first solution that
We would probably have rollers of some kind, instead of a friction pad maybe, which could be like a spring-based kind of thing, so it could like adjust to the angle of the rope, the cable. And then we could also have this a bit skinnier, so then there's like less surface area contacting the cable.
So this one doesn't have variable geometry as it slides down, but originally we did have an issue that when we put a lot of weight on it, the front would just tilt completely down. So even though we weren't able to fix that problem for a gondola line that would change geometry or change inclination as it changes, we were able to fix it for this one just by using these blue ropes to tighten them differently. So the front is a little bit tighter than the back. That way it keeps it a little bit more parallel to the ground.
Yeah, actually the whole reason that we made this taper was so that we can reduce the surface area contact onto this so that it can ride smoothly.
Time's up, you guys. Thank you very much.
Thank you.
That's what
I can take with your phone, yeah, with the phone. And then